that's on the tRNA. And so that would be complementary, so it would be UAC. Right? And so you have DNA, you have transcription, of that gene. So this contains the gene. So your DNA contains millions of genes, okay? And so if I'm just talking about one gene being expressed, that gene is being expressed through transcription into RNA. And all these RNAs participate in translation. And that translation will produce proteins. So basically, if you take this information here and put it into a essay type form to describe that, would be good.
Okay, so can we say the DNA codes by using transcription and the use of mRNA, RNA, rRNA for translation to the proteins? Pretty much covers it all.
Yeah, but you forgot to mention that was a gene. The genes that
Which is
contain
the
in the
gene
gene,
codes.
yeah, is going to be carries a code for a protein, and that process starts with transcription of the message from DNA into RNA. That RNA could be a messenger RNA, which carries the messenger, tRNA, which carries the transfer RNA, which carries the amino acid, and the ribosomal RNA, which works in the ribosome for translation. Translation occurs and creates a protein or polypeptide.
Right, to a protein. So gene DNA, which carry the gene codes by using transcription and use mRNA, RNA, rRNA for translation to the protein.
Okay, but did you explain to me that what the mRNA does?
It's the messenger.
Okay, I'll put messenger,
Did you tell me what the tRNA does and the rRNA does?
Okay.
Yeah. They're all very important.
Okay.
So as long as you can do that, you'll be good. Okay, and then we talked about, huh? I'm not trying to make it difficult.
I covered all of that in one long sentence.
Okay,
I'll just.
whatever.
He's not difficult, he just has a long way of explaining things. There's a simpler way to explain it, he just goes long.
He's just covering all his bases.
Sounds like what my wife says.
Just saying, I've got 3 classes with you.
She asked me a question, she asked me a simple question, well, what is this? And so I started telling her, like, I'm not one of your students. I'm like, well, I don't know any other way to explain these things.
We both got to the same point. You took a long word.
You need to like.
Yeah, but see, along the long route, it's scenic and you can see things. So I can imagine a mRNA chain with all the codons on there. And then I imagine the tRNAs coming in and dropping off their amino acids, and then they move on, and then another one comes in and moves on, and it builds this long chain of polypeptides. And then after it produces that, then it starts to fold and wrap around and become a three-dimensional shape, and now it has function. Now, okay. I like that. All right. Describe the difference between synthesis reaction, decomposition reaction, and exchange reaction, and give example of each one. And so when I'm talking about this, when you're saying describe,
I think you skipped one.
I did?
Describe the difference between covalent hydrogen and ionic bonds.
You're right, I did. Okay, so describe the difference between a covalent hydrogen and ionic bond. What is a covalent bond?
Covalent share electrons by 2 atoms.
So the characteristic is that they share electrons. Does it make a very strong bond?
Yes. It's hydrogen.
Much stronger than the hydrogen and the ionic bonds, right? So there's a very strong bond that is formed there because of the sharing of that electron. So, what about a hydrogen bond? What's the characteristic of a hydrogen bond?
That's the weakest.
They
Is it the weakest?
attract the partially charged to the polar partially charged.
Okay, so they're not sharing an electron, but they have a difference in electronegativity, right? And so that difference in electronegativity causes the attraction and the bond. But if we're talking about an ionic bond, right? Salt is held together by an ionic bond, right? What happens when I drop salt into water? It dissolves. Why? Because of those hydrogen bonds are breaking and forming bonds with the sodium and the chloride, pulling them apart. So obviously the ionic bonds can be somewhat weaker than hydrogen bonds, even though hydrogen bonds are weak and easily broken. So the characteristic of the ionic bond is what?
They occur when two atoms with different electrons come together.
Yeah, they have different electronegativities, right? But one donates the electron to the other. Okay, and this is not just a one-way street. It can go back and forth. And so you always have one donating the electron. So covalent bonds are sharing an electron. Hydrogen bonds, you have the electronegativity attraction, right? And then you have ionic bonds, which you have a sharing, not a sharing, but a donation of an electron, right? So be able to explain those things. That's probably going to be a short one. Okay, now we'll get to synthesis reactions, decomposition reactions, and exchange reactions. Now, when you talk about these, don't just do this, where you talk about with a synthesis reaction. If I do this, if I explain, well, synthesis reaction is taking two molecules and combining them to make a larger molecule. Does that completely explain to me about this reaction? Okay. What other things go into this reaction?
Energy.
Huh?
Energy.
Okay, so it takes energy to make this bond. What comes out of this reaction? Water. So you get water that comes out of here. What's another way of describing this? So I'm talking about energy.
It's endothermic. and
Endothermic.
It's anabolic.
It's endothermic and it's anabolic because you're building things. Okay?
Hydration.
Huh? And it's dehydration. So you might want to mention those things in there that synthesis reaction is the combining of two molecules to make a larger molecule. This reaction is endothermic because of the investment in energy, and it is also called a dehydration synthesis because of the loss of water in there. Therefore, building up of a larger molecule makes it an anabolic type of reaction. That would be a great answer.
Oh, can you say that again?
Okay.
Slowly,
I put,
calmly.
can you just put like synthesis slash endothermic slash H2O form
Slash.
slash larger complex molecules slash anabolic?
That looks more like a list than a essay.
You
Yeah.
gotta have words right.
So, wait, I have two questions. So, could I just draw that and then like, so I do it like you did,
Yeah.
and then like, can I say that it's endothermic because it has energy going into it, and then it's dehydration because the water comes out, but I don't know what that was. What did you say that was? The anabolic one?
Anabolic means that you're building up.
Building.
So because you put them together, it's anabolic?
Anytime you go from smaller molecules to making a larger molecule, it's anabolic. you're building up something.
So can I just draw that picture and tell you why it is?
As long as you explain it very clearly in sentences. And so, the decomposition reaction also what we call the hydrolysis reaction is also exothermic, right? And so it is exothermic. Why? Because energy is being lost out of it or being used. It is it's a hydrolysis reaction because water is going in to break that bond. Anytime you break a bond, you get a release of energy. Okay? It is catabolic because you're breaking down a larger molecule to smaller molecules.
It's
So-
what? What's the
Catabolic.
Catabolic,
Catabolic?
yes. I always associate catabolic with cannibalism because cannibals, they take a large human and they break it down into smaller bites. I don't know, how are you, huh?
I don't know, but that's so.
I used to think of a lot of weird things in grad school and college to remember things. Cannibalism. Just make sure you spell it right. Yeah, it's cannibalism, but it's not cannibalism. Okay, an exchange reaction. Exchange reaction is A, B plus C gives you A, C plus D. So what's going on here?
It's metabolic because it's endothermic and exothermic, and it breaks and forms quickly.
Yes, so everything is going on here. You're getting, number one, you're getting the release of energy from breaking that bond, because you also have H2O going into this. And here you have energy going back into this, and you have water going out of that. So you have both a synthesis and decomposition reactions going on, and so it's both endothermic, exothermic. It is also both anabolic and catabolic, okay? And so you should be able to explain that. If you can explain these two, you can explain this, yes?
Is it hydraulic and like dehydrated too?
Yeah, because you have hydrolysis, adding of water, and you have dehydration over here, right? Because it's exchanging. This is what you call, your metabolism. This is what's going on in your body right now. Yeah, metabolic reactions. All that sugary food you just ate to get into this class, now it's being metabolically
We
broken
have
down.
to eat that sugar because you take the wrong way around this, Perry.
Hey, I'm not in charge of your glycemic index.
Probably a good thing.
Well, it's good, because if you're on my diet, your life would suck. And see, you survive on a diabetic diet. No.
See, I don't have to, so.
No, you don't have to. I didn't have to either before that. Now I do. Now that's why I'm salty and bitter this semester. Because I'm starving all the time. All right. What? Is it almost time to go?
You have like 4 minutes.
Okay, so when we come back on Friday, we will finish our review. Saturday, 10 o'clock at the coffee house. I will be there.
Will you wait, what time?
10 o'clock.
Will you make that less complicated?
No.
Wait,
Will you explain it?
I will explain it, yes.
I don't get it.
How do you don't get it? Which one do you don't get?
How do you express something?
It's gonna be really short, like a really short.
How are genes expressed?
Yeah, that.
You could look into chapter 6 and I might explain it.
Into chapter what?
It's probably a little bit too deep there.
Not I know.